Welcome to my YouTube channel. Today we're going to do the problems related to time and temperature. But before solving the problems, we need to know how to perform addition and subtraction if we are given some time in hours, minutes and seconds. And also the most fundamental thing that we need to know or that we need to keep in mind is the hours has to be subtracted or added in hours, and also the minutes has to be added or subtracted from minutes, and the same goes with the seconds. So the second thing that we need to know is time elapsed. So what is time elapsed? Time elapsed is the amount of time taken by an event to happen. So the formula for time elapsed is end time. That means when the event ends, and minus the start time when the event starts. So now jump to the problem. So our first problem is Robin went to school at 7:45:15 a.m. and returned home at 3:10:26 p.m. So what we need to find out, how long did he stay at school? That means how much time did he spend at school? So staying at school is an event, and what we need to find out is the time elapsed. So as we know that the time elapsed is the amount of time taken by an event to happen, and here our starting time is this and our end time is this. And also we need to write everything in 24-hour notation. That means for example, if we are given 2:10 p.m., how we can write it down in 24-hour notation? 14:10. Also, for example, if noon is 12 p.m. and after that 1 p.m., and we can write it out 1 p.m. as 13 and 2 p.m. as 14, and that goes on. So here our start time is 7:45:15 a.m. and our end time is 3:10:26 p.m. So in 24-hour notation we can write it down as 15:10:26. So as we know that the formula for the time elapsed is end time minus start time. So end time minus start time. So as per the rule, we already know that seconds has to be subtracted from seconds, and same goes with the minutes and hours. So if we subtract 15 from 26, it comes out to be 11. And here if we subtract 45 from 10, but 10 is a smaller number, so we have to borrow from hour. So if we borrow 1 from hour, like here 14, and if we borrow 1 hour, so in 1 hour there are 60 minutes. So we already got 10 here, so 60 plus 10, 70, and 70 minus 45, it comes out to be 25. Like 60 plus 10, 70 here. So 10 from here. So 70 minus 45, 25. And here we got 14, and 14 minus 7, 7. So Robin spent 7 hours 25 minutes and 11 seconds at school. So our next problem is a flight that is 5 hours and 19 minutes long takes off from airport at 10:36 p.m. on June 15th from Toronto. And what we need to find out, when will flight arrive in Vancouver, which is 3 hours behind Toronto. So a flight has taken 5 hours and 19 minutes from Toronto on June 15th at 10:36 p.m. And when will the flight arrive in Vancouver? So here we are given the start time. So the start time is and in 24-hour notation we can write it down as 22:36. And also Vancouver is 3 hours behind Toronto. That means let's take an example, just a random time. If it's 8 p.m. in Toronto, so the time in Vancouver will be 5 p.m. because the time zone of Vancouver is 3 hours behind Toronto. And also we are given the time elapsed, which is 5 hours and 19 minutes. So we already know the formula of time elapsed, which is end time minus start time, but here we need to find out the end time. So the formula will be time elapsed plus start time. So if we add the time elapsed to the start time, it's so obvious that the flight gonna arrive in Vancouver on next day. So let's do the addition. Uh, 5 hours and 19 minutes. If we add this, so 27:55. But we already know that days of 24 hours. So subtract 24 from here, it comes out to be 3:55 a.m. But Vancouver is 3 hours behind Toronto, so subtract 3 from here. So which is 12:55 a.m. So the flight gonna arrive in Vancouver at 12:55 a.m. So now we're gonna do a problem related to temperature, but before that we need to know a formula of change in temperature, which is final temperature minus initial temperature. So delta T is change in temperature. So now jump to the problem. A frozen microwave dinner was 4 degree below 0 degree before cooking and 52 degree after cooking. So how much hotter was dinner after cooking? So what we are given is a frozen microwave dinner was 4 degree below 0 degree. That means our initial temperature when the dinner was frozen is minus 4 degrees Celsius. Why minus 4 degree? Because it is below 0 degree. and our final temperature is 52 degrees Celsius. So if this is a 0 degree and this is 52, and below 0 will be -4. So what we need to find out, how much hotter was dinner after cooking. That means we need to find out the change in temperature, like how much hotter was the food after cooking. So as we know, the formula is final temperature, which is 52, minus initial temperature, which is -4. So minus minus plus, so it comes out to be 56 degrees Celsius.